Whoa, look at this problem. You are going to solve this problem. Well, it is radical expressions, and they're going to want us to add or subtract them, but they have to be the same. And if you look at them right now, they're not the same. Not any one of these three are the same. So let's simplify them and find out if any of them are the same and if we can put any of them together or if we can put all three of them together. So let's notice that it's a cubed root. So underneath, we would need a group of 3 to take one out. And you might need to go back and take a look at some of the videos of simplifying radicals. So for this first one, the cube root of 54xy to the third. Okay, I'm going to split it up. Let's look at the 54 differently than we're looking at the x, and differently than we're looking at the y to the third. Okay, and I'm just going to simplify this one first all the way down. Then I'll tackle this one, and then I'll tackle this one. So the cube root of 54. I come over, I look at my cubed roots over here, and I do not have 54. So I'm looking to see if any of these numbers go into 54. And 27 goes into 54 2 times. So now I'm going to rewrite this as the cube root of 27 times the cube root of 2. 27 times 2 is 54. All right, here's the cube root of x, and drop down the cube root of y to the third. Now let's simplify. I know that the cube root of 27 is 3. So here's my 3. I don't know the cube root of 2. I don't know the cube root of x. Do I know the cube root of y to the third? Sure I do. 3y's inside gives me 1y outside the radical. So this term now is going to be 3 outside the radical, y outside the radical, and then 2x left underneath. Okay, so I've completely simplified this first radical. It is 3y cube root of 2x. Now let's look at the second one. Let's look at this right here. I have a 5 on the outside, okay. Underneath that cube root, I have 2xy to the third. Now I don't know the cube root of 2 or anything that goes into 2. I don't know the cube root of x, but I do know the cube root of y to the third is y. So instead of splitting this one up, I'm just going to take this y, and it will come right here, and there's going to be 1y outside the radical. Okay, so minus 5, here's the y, and then the 2x stays under the radical. I could tell just by looking at this that I couldn't find the cube root of 2 or x. Okay, so this term is simplified. Let me go ahead and drop it down. So this is going to be minus 5y cubed root of 2x. And now let's look at the last term. Plus y cubed root of 128x. So I know I don't know the cube root of x. Do I know the cube root of 128 or anything that goes into 128? I come over here and I'm looking at my cube roots. 128 is not a perfect cube root, but 64, if you know any binary numbers, 64 goes into 128. So 128 is 64 times 2. So for this term right here, I'm going to drop down the y. Cube root of 128 is going to be cube root of 64 times cube root of 2. And the x is still under the radical. I could split it up, but I don't really need to. These two could just be together. Okay, let's see what I have. Plus y, the cube root of 64. What's the cube root of 64? 4. So this is going to be 4. And then the cubed root of the 2 and the x both go back together underneath the radical. Okay, so let me bring this down, and I'll write it the right way. Instead of y4, it's going to be 4y. So let me bring it down. We have plus 4y cubed root of 2x. Okay, so all I did was I simplified this, and I simplified this. Now it's time to see if we can combine them. So, like terms, I have 3y cubed root of 2x minus 5y cubed root of 2x plus 4y cubed root of 2x. They're all going to go together. So 3 of them minus 5, that's negative 2, plus 4 is a positive 2. 3 minus 5 plus 4, you could do that in a calculator. So this is going to be 2y cubed root of 2x. Nice.